Well, hello, everybody. Welcome to this month's First Friday. I'm Rich Dione, Associate Professor of Practice in Theater and Co-Director of the Fusion Studio for Entertainment and Engineering.
Hello, everyone. I'm Mary Pilot, Co-Director of the Fusion Studio with Rich, Associate Professor of Engineering Practice and Director of Multidisciplinary Engineering and Interdisciplinary Engineering here at Purdue.
We are excited to welcome all of you to this month's First Friday at Fusion Studio. First Fridays at Fusion Studio 1-hour virtual workshops provide a monthly opportunity to discuss emerging trends and technology in the entertainment industry, engage with industry experts and practitioners, and explore scholarly works. This month, we're thrilled to have with us Dale Hourlland, Engineering Manager, and Patrick Finn, Product Manager from Wenger J.R. Clancy. Wenger Corporation recently announced the release of the Vantis pendant controller for rigging, and Dale and Patrick are here to share with us the engineering design process at Wenger Clancy and how it led to the development of this new and unique product. And y'all are here to listen to them, not to me. So with that said, I'm going to turn this right over to them immediately. So welcome, Dale and Patrick. Thanks for sharing your time with us.
Thanks, Rich. Thanks for putting this together. Glad to be here.
Thanks, Rich. Thanks for having us.
All right. So without further ado, we are thrilled to have you here to talk about the design process for a couple of recent product development projects, some control enclosures. So these are our control systems that we use for rigging and motion control, and the design process that goes into coming up with the idea, bringing the idea to fruition and taking it through. So just so you can get to know us a little bit, I am Patrick Finn. I started with Wenger J.R. Clancy back in 2009. Prior to that, I worked as a technical director in regional theater and opera up and down the East Coast. I spent a little bit of time in theater consulting before making the jump into manufacturing and contracting and theater equipment. So I've been doing that for about the last 11 years. Worked in project management before getting the opportunity to move into product development, and now focus in on all of our products and coming up with new ideas, maintaining the existing product line, taking a look at what's going on in the world and what might help theater operators do things more effectively or have more capabilities. Dale Hourlland, our engineering manager, let him introduce himself.
I'm the engineering manager for the Syracuse office and J.R. Clancy brand for Wenger Clancy. I came from a strange background. I have all of my education is in theater production. I did production work for quite some time before winding up running a performing arts center in small town central Pennsylvania, where all of the entertainment is brought into the campus by the campus because there's nothing there. So I was there for about 18 years before leaving the university and coming to Clancy as a controls engineer, and that was in 2011, and somehow I wound up sitting in this chair. Well, sitting in the chair of managing the engineering departments in Syracuse. So a lot of my experience is with J.R. Clancy automation systems, and I come at this from an end user perspective. So that's my contribution.
All right, so what are we going to talk about today? We're going to talk about the process of how we come up with an idea, how we take that idea from an idea to an actual concept, how we take the concept into an actual design and into something that could work, and then how we get it out and ultimately start building it and putting it into theaters. And we're going to go through two case studies. So the first is going to be our Scene Control 12. The Scene Control 12 was a new console within an existing line of consoles, all running the same software that we've been running for about 7 years. And we built that new console for a specific purpose, and we'll get into that. And then the Vantis pendant is the most recent. The Scene Control 12 launched in 2018. The Vantis pendant just last fall. So I think it was in September that officially came out. So that's the newest one, and that's actually both software and hardware. We're going to focus mainly on the hardware in this portion. We'll talk a tiny bit about the software development as well, but we're going to talk about the mechanical design, the feel, how we got from, hey, this is what it might do to where we are today. So without further ado, looking at the Scene Control 12. how did we come up with this idea? Well, what really happened is we had a project overseas where we had to provide a 12-inch console. This was an international project. A 12-inch console was a requirement, a 12-inch mobile console that you could carry around. And we didn't have this product at that point. So we had a 10-inch screen and we had a 15-inch screen. The 10-inch was our mobile one. The 15-inch was our desk console. We did not have a 12-inch console to fit this. So we had to sort of fast track an idea, rush something through. And we came up with an idea that worked fairly well. It was a 12-inch console. We called it the Scene Control 5400. It was really only provided for this project. But throughout the development of it, we fulfilled the project requirements and provided a perfectly workable system. You can see here, we ultimately ended up building this product as a custom solution. But as we did, we identified some key areas where this could potentially have some improvement. So we learned from what we built quickly and thought, you know what, this is a really good product fit if we can just improve on some of the ideas that we rush through and make them into a more meaningful product. And the ideas that we came up with for improvement.
Let me stop you. This console was a requirement for a project, and we had to build it within the budget for the project. The reason that we went on with developing this for that individual project was the project was too big to turn down. So this was an enormous, it was about a $10.6 million project, and it had this requirement in it. So we needed to have a purpose-built console. So that's how it ended up with, we wound up with something that is hanging around this guy's neck here.
Exactly. And to be frank, it worked well. It functioned for what it needed to do. But when we held it, as you can see by the big strap around his neck, it wasn't necessarily the most comfortable to carry around the stage as you're moving things around. It was a pretty substantial piece. The grips you can see on the side, that little yellow piece you see right here, there's one on the other side as well. Those are what we call the hold to run operator. The hold to run operator is a device that tells the system, hey, I'm here and I'm intending to operate this system. So you press those down and that enables you to initiate the motion control. They're actually a 3-position switch. So you have open where you can't move anything. Then you have engaged where you can operate the system. And then you have the overly engaged when something goes wrong, you grip your hands really quickly. That would put the system into a fault. And that whole concept in that switch design is driven by the standards for automation control in the industrial industry. So that's integrated right into the console. But as we worked with it, we decided it wasn't really at the most convenient place with one hand here, trying to hold it up and in there. What we really wanted to come up with was a system that did not require a neck strap. You could hold it with one hand and integrate that hold to run switch with a single grip. And therefore much more easily move around the stage with it. And then it needed to be comfortable enough that you're holding this here for quite some time. This is this is a motion control console. It needed to be comfortable enough that you could hold it for quite some time without tiring, without fatiguing. So trying to find the right balance, the right shape, the right grip, the right weight to make this a successful console was a big challenge on this one. Another one was finding an appropriate computer that could fit into that within the weight requirements. And we'll talk about that on this next slide. So one of the first challenges we found when we were working with this is we wanted to have a mobile console. With that, we needed some sort of mobile computer. And building a computer from the ground up, from scratch every time that was going to be durable enough, that didn't require massive amounts of tooling, that really isn't feasible with the quantities that we work in. When we build consoles, we build them in the tens or the hundreds. When computer companies build computers, they build them in the thousands, the tens of thousands, the hundreds of thousands. And they invest a lot of money in the tooling that goes into that product, not necessarily available when you're working on such a small quantity as we are in our industry. So we had to find a computer that was available that had a robust design, but also had all of the communication and the hardwired network ports that we needed for the safety of motion control. Because when we do motion control, we want to make sure that we have consistent communication throughout the system. You look at most of the tablet computers that are on the market, the Microsoft Surface, or I have the Dell equivalent sitting in front of me. None of them have an Ethernet port anymore. They all have a USB 3 that can be used as that, but that's not necessarily appropriate for motion control, where you need that consistent communication.
Yeah, you really can't use a USB port for a hard operator. If how many times have you had your mouse stop communicating with your computer? Imagine if your mouse was doing the work of stopping a hoist that's running at 80 feet per minute towards somebody's head. That's something that you need to have control of all the time. So we needed to make sure that we had proper communication with the computer in order to be able to safely maintain control.
Exactly. We don't have time to unplug and plug back in the USB port
or restart the
in
computer.
that circumstance. So we searched for quite some time, and we ended up forming a partnership with a industrial computer company, Tiguar, you can see right there, that has a whole line of industrial computers that really worked well for what we were looking to do. And they were willing to work with us to make some customizations to make it work for what we needed. So we were very fortunate to come up with this company and identify this computer. What you see here is the 12-inch tablet that ultimately becomes the centerpiece of this console. So next up, how do we hold it? So you can hold this console in your hand like that, this computer rather in your hand like that. But unfortunately, that's not quite enough for everything we need. We need an emergency stop button. We need a go button, a stop button. We need that hold to run. And we need to be able to do all of that while holding it and operating it with our other hand. So the first thing we decided we needed to do was develop the handhold that would enable us to hold this with one hand comfortably and actuate that hold to run button in some way. So we started talking about, hey, how do we develop this handhold? Where does that what does that shape look like? Where does it sit? Do we hold it on the left side or the right side? And Dale came up with the idea of modeling this after a rock gym climbing grip. You can see here we have a similar shape to that right there. If you've ever been to a rock gym, you know this is probably your favorite handhold to come to, because it's by far the most comfortable you can get a grip. And Dale did a lot of work to purchase some of these, feel them out, feel what shape worked well, and then work that into a design that he felt would work well. Dale, you want to talk a little bit about that?
Yeah, I had a specific requirement in my head of having something be workable for somebody who was left-handed or right-handed. And this is where we sort of got into the idea of, rather than making a product that is specifically for a project where we're just meeting the specification, let's make a product that will work for an operator so that they can hold it in their hand and it can be comfortable, and it just needs to be something that you don't want to, that you're not going to be afraid of picking up and walking around with. So I think the idea of the rock gym hold actually came from a rock gym. I think this actually came from a rock gym in Lidditz when we were down there for a meeting with somebody. That's where this came from. It was just like, hey, this would be a really cool idea. So I talked to a few industrial designers, and we have a relationship with one, and we mocked one up out of clay and shaped it so that it could go onto the back of the console. And that's it. That's from a number of years ago, sitting on my kitchen countertop, the clay model, and these were the measurements these are the photos that I sent to a company that was going to scan these for a 3D print of the same thing.
Exactly. Actually, prior to the 3D print, after we had this in clay, we positioned it and got it, sort of in the shape that would fit multiple hand sizes. We decided we needed to validate that and started with a foam carving. So we took the foam carving and modeled that grip in there, but then started to build in, hey, where's your thumb going to go? What's that relief need to feel like for where your thumb fits? As Dale mentioned, this is something we wanted to make ambidextrous, a left or a right hand hold position. And it was at this point that we really started to run into an issue there, because your palm on the one hand needed to have support where your thumb needed relief. So vice versa, you needed the opposite. And we didn't necessarily find a perfect grip that was left and right handed. probably a reasonable pause here. The original concept was you could take the console and flip it over to make it left-handed or right-handed.
No, the original concept was that you could take that handle. If you go back to the other,
that's right.
Yeah. That handle was going to be on a device that would let it spin.
Yep, that would let it spin around.
Stay upright.
And we didn't end up getting that to work. So we ended up having to do a little bit of backward working to make the left hand position work on the opposite frame. So you can hold this with the opposite hand. It isn't quite as optimized when holding with the right hand as it is the left hand, but it is feasible. And it's something you'll find in our later slides that we try to improve on the next design of the next console. So from the shape studies here, we started to move into the 3D printing and really trying to refine that shape to get that right. So you can see several iterations. We started here, we moved into a 3D print here. It's a little dark to see, but there's not quite the same relief, and ultimately ended up with this shape right here. And you can see the hold to run button integrated right in there. I'll show that on the next slide. Here, your hand wraps around here and your fingertips rest very nicely right on the tip of this. So as you're holding the console, you are very easily able to engage that with very little pressure and still support the weight of the console. Another nice portion of that, you were able to drop it down to your side and hold it while you were watching the moving sets after you've initiated the motion control, and keep that motion control engaged. So this was a key portion of the really touch and feel of this whole product, was getting this weight centered properly so that you could hold it with little effort, but still safely and easily operate this switch.
There are two forces going on here. You've got to be able to hold the 4.5 pound console, and you've got to be able to operate that switch independently.
Exactly. So you saw in the previous slide, we had basically affixed that grip directly to the computer. From this point, we started to work on what a full enclosure might look like that would encapsulate the go, the stop, the hold to run. So we built that into a 3D model that would be the entire enclosure, and you can see that grip now molded into the back plate of the console. And this ended up being a 3-piece enclosure. So we had a back, we had a front, and then this insert right here that appears gray right there, that's a separate piece. It's a separate piece because of molding capabilities. If you don't know injection molding, you can't have complex shapes that don't allow you to remove pieces of the tool. So there's a steel tool that would go around this. In this case, we used a urethane tool, a plastic tool, and you pour in or inject in the plastic that becomes the part, but you have to be able to remove the tool. So you can't have things that would be captured in there. And this would have been a place where we'd have a captured tool. So it had to turn into 2 pieces that are fixed together on the inside. And then ultimately that became that model. We decided we liked it. We got all of the pieces, parts integrated. Here's an early mock-up. We have our go and our stop button, our joystick, our e-stop would go right here. You'll see that in a moment. This is an all 3D printed version of this mock-up. So you can see the 3D printed faceplate right here. We'll go to the 3D printed back plate. You can see all the little lines in here. So that's the filament of the 3D printing, building this up. There's various types of 3D printing. We did the filament style, which is the most cost-effective, but really works well for us in terms of getting something quickly to prove out that it's going to fit together, that it's going to work before we go in and invest in heavier tooling that enables us to create these in volume. So there's a key step in our development process. And you can see this is really where we're getting into the design development. We've had the idea, we've worked through the concepts. Now we're making that design work in reality. So here's the back plate, and then I'm going to look at the side here. This is a fun challenge. You can see right there, there's a break line. There's the difference between the face plate and the back plate. One of the things we had to do was maintain access to some of the key ports that were available on that tablet computer. So this, what you see right there, is actually that tablet computer exposed. So we have our power button there. We needed that in case of a hard reset. The USB and USB 3 devices right there. And then other devices are our reset button here. All integrated into this enclosure. And eventually this would become a prototype that was made from plastic tooling, eventually into the production level that we sell and deliver today. So, Dale, anything you want to add in there?
No, I think you covered it. I mean, I think I was trying to remember how many different 3D printed versions we had. I think we did 3 or 4 different versions as we held these things in our hand and tested the handle with different size hands. We actually had different people hold these 3D printed models to make sure that somebody with a large hand would be able to would be comfortable, and somebody with a very small hand would be comfortable. And we made changes as a result. Changes so small as changing the cutaway in where the thumb landed, because it was I don't remember, it was either too there wasn't enough room for somebody with a larger hand, and they weren't comfortable, so we changed that shape. The corners, the corners were a lot sharper in one version, and we found that in certain positions, the corners of the console, on the outside corners there, in certain positions, those corners would catch your forearm. So we did some curvature on the edges of the case for the corners there. And then I think we either wound up shrinking the whole case thickness or expanding it in order to accommodate internal components and facilitate assembly, because there are 3 internal components counting the computer and then the operators on the front. And the wiring inside this console gets kind of complicated for a fabricator to put together, because it's a lot of stuff that's crammed into a little box that's not really evenly shaped inside.
Yeah, what you don't see is integrated into this back plate on the inside, there are standoffs or bosses built into the plastic itself that are sized appropriately to mount all of the internal components. So there's a big there's a card right here, a computer card right there that we mount this to. There's other little equipment in here.
There's actually a network switch in there.
A network switch and a USB hub, I believe.
Yep.
All living within that component right there behind the computer. Whoop, back to that. So behind the computer right here, that's where that card is living. Behind over here is where all of our components are. As I'm sure you can imagine, the back end of these take up space. So we have that. And then all of the wire routing had to be coordinated through this and make sure that we have the wires going through, and that you could take the faceplate off and service it, or just to assemble it to start with. So when we got to this point, we were feeling pretty good about where we were, but we still needed to figure out how this was actually going to work in the field, what we were going to do with it. And one of the questions we came up with is, how do you store it? What do you do with it when you're not working with it? We came up with sort of 2 use cases. What do you do with it when you're done for the day and you want to put it away and get it out again tomorrow? And what do you want to do while you're working, maybe programming something, but coming on and off stage, and you want to just set it on a desk?
Yeah, that actually was, what does Patrick want to do with this at the trade show to display it, which is where we wound up with the first stand that you're about to see. This was developed right before USITT and launched at USITT, and we had to have a way to display it at USITT. So we came up with this design for a desk stand. And I think when we got to the show, we bought a wireless keyboard so that we could demonstrate programming of cues, and we wound up with a wireless keyboard that was just by dumb luck exactly the same width as the console itself. So we had something that looked like a little laptop sitting there on a table. Sorry, I had to get my digs in, Patrick.
Yeah, well, just because it worked for the trade show and actually working on it. And
Yep.
I see a question here for what's the typical R&D cycle, and that's a really fun question for this particular product. It can vary very wildly. We've had projects last 2, 3, 4 years. This particular project, I believe we kicked off just after the new year in 2018. And we brought it to USITT at, I forget if that was the year.
It was March.
It was the very end of March that year. This So it was a very, very fast track project on this one. Indeed, this was a serious endeavor for us to get done.
Yeah, and in terms of, I see another question about, is there anything, any consideration for the computer? The consideration was, let's find a ruggedized computer so that we have somebody else doing all of that drop testing for us. The computer itself will survive a drop. The case probably wouldn't.
Yeah.
You know, and we had one user who had their console on their grid, and they did drop it, and it hit the grid steel and broke the case. So they shipped it back. We put a new case on it, but everything else was fine. So there are consideration. The consideration was exactly the opposite of the question. The computer is probably the more robust component there. But yes, we did consider that. We wanted a ruggedized computer so that we didn't have to worry about it.
I'm scrolling back through the comments that I had been ignoring. Small, medium, large, we don't, and I think Dale touched on that a little bit. We really worked hard to try and make sure we didn't need that small, medium, and large, and that it would accommodate the various hand sizes. So yeah, and yes, as Dale noted, most certainly selecting that ruggedized tablet was key to making sure that we had more confidence in the drop testing, and that the computer and that the console was still going to function in that circumstance. So I mentioned the other storage condition. What happens when you want to put it away for the evening or just not be working with it for a while? We came up with a wall mounting method here that you can drop it down, have the face inside, because if there's anything I know about stagehands like Dale, the first thing they're going to do is lean a flat up against it. That probably was more guilty. But yeah, so we wanted to make sure it was protected. You can see we have a standoff here. We adapted this a little bit since this original prototype, but standoffs so that the operators here are not rubbing against the wall. And then you can easily pick up and walk away with it, work, and then drop it back in. And these are just the first renderings of those. Those were done in SolidWorks, bent sheet metal, fairly simple shapes. And pretty easy to turn into what you see right here, the actual product. So, all right. So with all that, we took that product eventually to, and I apologize, I didn't have one with the joystick mounted. I think we had stolen the joystick for the other version, and it got put in here at USITT. But this is the first unit that we delivered. I think Dale, you probably have a better guess on this than I do at this point, but. How many of these have we shipped in the last 2 years?
I would say we're probably around 100 now, just based on how many times we've had the tooling rebuilt to make the cases. We're probably between 75 and 100 at this point. There was a question about redundancies. The redundancies in terms of motion control and operation, all of the functions that are delivered by hard operators are deliverable by the software, with the exception of the e-stop. In terms of electrical, all of the electrical functions that are performed by the operators are performed with 2 contacts. So there is a confirmation, for example, that the go button is being pressed, because there are 2 contacts in the go button, and one of them is being monitored and one of them is actually performing the function of pressing the go button. The e-stop the same way. There are two contacts used in the e-stop, as well as the hold to run. The hold to run is using 2 contacts as well. So in terms of redundancies, if one of the hard operators fails, not only will the software know it, but the software has functionality that we can change it so that we can have for example, if we lose operation of the go button, we can put a go button on the screen.
A couple other questions. Neck strap. So we did talk about whether to integrate a neck strap into this one. It was a conversation. We ultimately decided that it was more. We mocked it up with it and found it was more in the way than it was helpful, at least from our perspective. So we ended up going away from that. It's an interesting thought to taking a quick note, being able to drop the weight without dropping the console, but we felt that the ability to drop it down to your side and work with one hand was good enough for that circumstance.
Yeah, let me throw something else out there as well. The cord entry, a lot of the mechanical design of the case that we've just kind of forgotten. The cord entry lands at the crook of your elbow. So the weight of the cable set is greater than the weight of the console itself. The console weighs about 4 pounds. That original console that was built per a job specification weighed about 8.5 pounds. So we cut the console weight in half, and we maintained the cord at a place where your arm is just normally used to having a lot of force. So the cord doesn't actually add a lot of inherited weight to the console. So when you are holding this and you hold it down to your side, it really is as if your arm is just relaxed and you have full functionality of your other hand. So we did think about how to suspend this from yourself for when you needed an extra hand, but it's easy enough just to hold at your side. It's easy enough to put down on a chair, put down on a music stand, something like that.
All right, we got 3 more questions. I'm going to knock those out, and then we'll jump into the other one, and then come to more as we jump into the other one, just so I don't hold you guys up later. What material was used to cushion the device between the mounts? That's an excellent question. You can see it in this photo here, and the answer is the wrong material. This was this is our first prototype, and it cushioned well. It did a good job protecting the case, but it was a little sticky. It had a little too much surface tension, and it would scrape in there, not scrape, but sort of bounce down as you dropped it in. So we've replaced that material with a more felt-like material. It's adhesive back. We get it from McMaster-Carr probably.
It is an industrial felt that's adhesive backed from McMaster-Carr.
There's a question about beta testing. How much we have customers and end users work with the product before we roll it out. That depends on the product and the timeline of the project. We try to do absolutely as much as possible. We work with end users who are going to use it every day. We work with theater consultants who are often specifying projects on the behalf of the end user. So yes, absolutely try to do as much as possible. I know we had some user feedback sessions on this endeavor, USITT 2016 or 2017. We had a big session, and it was it's probably 17, and then a year later we came out with this product. What is the cable length? That's a 30-foot cable. That's our standard. We can go longer, but it gets a little difficult to roll up if you get too much longer. And then main operating position for the control system. Yes, but this system is designed to integrate with other consoles. So we've had projects where we've delivered the Scene Control 12 as a secondary console to one of our larger consoles, like the 24, the 24 Plus. So you might have a desk console somewhere to serve as your main hub, and this is more of your highly intelligent pickle. So we've delivered these both as a primary and a secondary. All right, so with that, I'm going to jump into the next product. So we launched this in USITT of 2018. Then took a step back and said, what do we want to do with our overall control system going forward? And we started to look at each of the products, and we really we learned a lot about how we wanted to interface with the software, but also with the hardware. And we decided to take a hard look at our existing product, the Scene Control Pendant. Scene Control Pendant was up to 8 machines. It was only controlling one of them at a time. It could do some targets, but it was a little clumsy, and it was using this industrial interface, not a touch screen, little operators there to go up, down. It felt a little bit like playing that old football game where you go up, back, left, right. So you're just a little dot. It had some room for improvement. And we had a project specified really with the idea of a main curtain controller that could do a couple of intelligent things, but all through hard operators. We had sourced, I apologize, this isn't in color, we'll have a rendering of it later. We sourced this enclosure, and we said, you know what, wouldn't it be nice if we had a pendant that could do a little bit more, could do all of these key things, control 8 machines, do targets, have permissions for different users, be ambidextrous, do load sensing, do variable speed. And we could mount it into this enclosure that we just found and used for this custom project. So we said, let's take a look at what that type of console might look like. And we came up with an initial concept using actual physical buttons to do everything we just talked about. So you have 8 machines that you can control. You have variable speed, you have targets, you can jog in and out, you can record things. And this is where we started and had some good ideas around it, but we took a hard look at like what the flow would be, where your fingers would need to go in any order. And we really determined that, boy, it got a little complicated, and this wasn't the cleanest way to lay everything out. So we decided to take a step back and say, all right, what are our user feedback device options that are out there? And we laid this out in a number of different ways. So just a simple bar that could show maybe roughly in space where it is. Here we show a slightly different screen, a little bit more information you can show there. Here we have a non-color touchscreen, and here we have a color touchscreen. We evaluated what the pros and cons of each of these are, and getting rid of all of the hard buttons up here, putting them right into a color touchscreen, being able to tailor the interface based on what's going on really became attractive. And we were surprised at how inexpensive we could get a reliable touchscreen for. They've really come down.
Yeah, if you think about what's behind these, if you look at the console on the left with all of the push buttons and just the minimal display compared to the consoles on the right with the display with less hard operators, you still have the hard operators that you need for safety. But if you imagine all of the wire that goes behind those two versions, the manufacturability of the touchscreen version is a lot better. It's easier to service, it's easier to make, and it's easier to just put it together. So
with that, we made a selection and said we are going to use the color touchscreen option. We moved forward with that, but while we were doing that, we were also doing a little bit of a study on the shape of the overall object and how it was going to be to work with. And one of the things we determined, and this is jumping back to the other version, but it was going to be really difficult using this enclosure and the off-the-shelf touchscreen size that we found to interface with the whole thing because the enclosure was so large. If you ever worked on your phone and as they get bigger and bigger and you can't reach that top left corner with one hand, we wanted to avoid that. We wanted to make sure this was something that you could operate fairly easily. So we said, you know what, we cannot use this off-the-shelf enclosure. We searched around for other options and just didn't find something that would give us what we were looking for. An ambidextrous.
It's also impossible to hold. You just can't hold this with one hand.
So we said, all right, what are we going to do? We got to make something. And coincidentally, we were working on some other conceptual designs at that point, and we had focused in on one of our pickles, if you will, the remote operator for another console we were working on. And this is where it all started. This was the idea for the concept. We said, all right, let's take that shape and let's see if we can fit it into that with some custom made shapes and materials. So started by mocking it up with this concept rendering, and we said, all right, let's run with this. Let's see what this might look like. Now, this looks pretty small compared to what we ended up with because it ultimately ended up a little bit larger because of all the components that Dale just mentioned that had to go in there. But after we fit them all in, we said, what might this look like and how can we build it? So we came up with the idea of a rear extrusion. So this is an aluminum extrusion that runs along the back plate, and the extrusion is a piece that you have to have tooling for. You have to buy a die and you push the metal through that die. It's just like a Play-Doh extruder, except a little hotter and a little heavier. But this was the concept, come up with a rear extrusion that we could cut to length, make this any length that we want, and then drop the faceplate in there, put the touch screen, the go, the speed operator, and the e-stop right here. And you can see we had the go button here, speed operator, jumping back, and the touch screen. And then we said, we're going to want some sort of strap. So this is easier to hold, easier to not have the weight on your fingertips for the entire time. but we want that to be both left and right. So the idea was, can it swing from the left side to the right side? Does it detach and reattach, or there are two of them? More to come on that. And then inside, we wanted this all to be easy to put together. So inside of this, we built a little tray that is the tray that all of the computer components mount to. So everything stacks up right there and mounts into this tray. You can see these little punch outs here. These are actually places to put wire ties to do the cables that run past this unit. So it became a pretty simple thing to fabricate, where you drop this onto the faceplate, you put the faceplate into the extrusion, put your end caps on, and you're done. All seemed like a good and simple way to go, but the next step was to try and move forward with a 3D print.
Take a note at the shapes here. These were shape studies. No, go ahead. These were.
Yeah, so we have a question. How often do you use Raspberry Pis for pendant controls? In this one only. So Raspberry Pi has come a long way in terms of its capabilities, stabilities. It's being used in industrial electronics and automation pretty significantly now. And we decided it's the right form factor, it's the right shape, it does what we need it to do. It's not driving the motion control. The motion control is sitting back on the wall, and it's in an industrial PLC, programmable logic controller. This is controlling the user interface and the screen that you see right there. So comically, the Raspberry Pi is actually way more powerful than we need it to be for this product. So yeah, I agree, Rich. Good catch, Luke. So with that, we went to some shape studies and started doing some 3D printing. So Dale.
Yeah, we needed to be able to feel the shape of the box, and if you look at A, it's got a flat front with the same shape back, and if you look at B, there's a curved edge with a flat front, and then if you look at C, there's a curved edge with a curved front. The face of C is curved. That was really for aesthetics more than anything else. What we found was that B was the easiest to hold, because B or C, because your thumb, the inside of your thumb wraps around that curvature on the front, and your fingers are able to wrap into the concave back, so you can really hold on to this with one hand and grip it with the ability to still use your thumb. That became kind of important.
Exactly, and you can see we took B from this 3D print to a full-size 3D print over here. So this is an all 3D printed mock-up that we worked up. So the faceplate fits into a groove in the extrusion. It looks a lot like what you saw in that earlier cut, but slightly different to make it a little bit more manufacturable. And then we have end caps, the top and bottom end caps that cap it off and house that emergency stop, as well as the strain relief down here on the bottom. So as we're holding it, this is now a comfortable shape. It's rounded in the appropriate places for your hand to get around it. But we still wanted to have a strap that would be a little bit more stable, so you're not dropping this thing, so you're not tiring as you're working on that. So we started looking at what that strap might look like, and we had a couple of different swing around options. You can see here and here. Here we have one that would mount into the side, and we found that these were going to be difficult to integrate with the emergency stop. We did not want to have any potential risk that this could stop you from getting into the emergency stop. So we ended up putting both of these on hold and focusing in on the rifle quick connect strap right here. And we decided we'd mock that up and see where that needs to fit. So we took it, we built a 3D model of the end caps, and we put a bunch of different mounting points on it the whole way around the entire thing to figure out, hey, where does this thing want to be? And what we ultimately decided is we wanted to have it on either side, roughly centered, to make a nice hand strap, roughly where you see it right here. And we ended up building that right into the end caps. So you can see this little insert goes into the end cap, and this mounts into the end cap there. And you can see here, it can move easily from one side to the other. So that's what we ultimately ended up with for our strap, moving from one side to the other. That
Look how far we got here. We're all the way to doing strap studies, and we figured out in doing the strap study that the go button was just plain in the wrong place. So if you go back a couple of slides there, go back one more. You'll notice the go button is down below the operator's thumb. Couldn't reach it. There's no way. You would not be able to operate this. So we got all the way this far in the design before we realized, just by holding it in our hands, hey, the go button's in the wrong place. So we wound up making that change pretty late in the game.
Yeah, good point. I actually kind of forgot about that. So, so this is pretty close to what we end up with. So here we have an all 3D printed model. We mentioned the extrusion earlier. It takes some tooling, takes some time to get into production. That was our next step, is let's get this extrusion made. So we've now proven the geometry throughout, and we made that extrusion. You can see here now that we just have this simple slot where the faceplate goes in. The faceplate sits right there, and now we've proven the extrusion. I'll point out here, this was an earlier version of the end cap that didn't match the extrusion. So you'll see that we had to revise this end cap to better accommodate to accommodate the actual shape of the extrusion. I think the extrusion grew towards the end of the project because of some of the things we needed to fit in there, running the cables along the side here.
We also had to confirm tolerances as a result of the extrusion through the die.
Yeah, yes, that's an excellent point. When you make an extrusion, you make a shape in your whatever CAD program you're working with, SolidWorks, and you send it off to the extruder, and you have to tell them what your tolerances are within what extrusion can do. Because when they make an extrusion, they're going to cut your tool, but the metal actually continues to change shape after it's pushed through. So what you end up with might be slightly different than what you originally drew. Now, the company we worked with ended up nailing the print almost exactly. We were pretty impressed with it, actually. One of the better ones we've had. So yeah, that was a big endeavor as well. I apologize. I'm reading a couple of the questions. Is the circuit electronics design completely fleshed out at this point? Thinking about size considerations and flexibility while developing. Yeah, that's a question.
It wasn't. We actually wound up changing that little bent sheet metal tray that we're using to hold all the electronics. We actually wound up having to change that because we experienced some supply issues with the computers, and we considered changing models, and we wound up with a slightly different format. So while while all of this is going on, the electronics design was a concept. The electrical design was a concept, and there you might consider manufacturability again. We want to be able to take these end caps off. So there are connectors in there. We had to figure out what those connectors were, and you can't really do that unless you have the physical space that you know you're going to have to put the connector in. So these were iterations that happened along the way.
Perfect. And I'll make one more note on that. This photo was probably taken in February or March. We were rolling this out with the intentions of late spring, early summer, and some of the components that we had specified to fit into this became suddenly unavailable because of the COVID-19 lockdowns that were happening in March and April. We lost complete access to one of the components and ended up having to redesign some things internally and work within the confines of that. And that's one of the things we knew going in is once we have the shape, we're going to have to stick with that. So, and MJ, we did indeed test this with different sized hands as well. And it's one of the reasons we ended up with the strap that we did. It's an elastic strap, and it has a lot of grip onto your hand itself. You can actually hold it with no grip at all. You can just do this and it'll hold there. That really helped for different size hands. So we got about 4 slides left, and then we'll jump into some questions. So like I said, we developed the extrusion, tested it all out, and then went to production for all the other parts. So we have the end caps here. We have a top and a bottom end cap. We have the machined faceplate. And then we tested out various finishing types. We looked at powder coat, we looked at anodizing. This is all aluminum, and we ended up going with the anodizing. And we were able to engrave the logos in there, which ended up looking pretty nice. There was a question about the electronics a little earlier. We didn't talk about this one because we only had an hour, and clearly we're running out of time as it is. But all the while, in addition to the electronics, in addition to the enclosure, we're also developing the full software, interface, motion control. I saw earlier good old whiteboard design. Dale, Dean, and I sitting at a restaurant in Syracuse because we had to leave the office so people would leave us alone. I think we showed up there at 11:30 and we left at 6:30. I'm not sure they're thrilled with us, but we fought and fought over where things should go and came away with this. And boy, if it didn't end up fairly similar as we came out. So after we had everything wrapped up, we decided to do what's called a beta site. We install one of these and put it to the test. We had a theater in North Carolina that actually I used to work at. I was the TD there. I have a good relationship with them. They already had a JR Clancy control system. And we said, hey, if we come in and replace your control system, would you be interested? We'll come in and do it at our cost. And we went in and we replaced their entire control system with this one. And here you can see the ultimate result. This is the Brevard Music Center down in North Carolina with the first system. So I'm going to jump to the next slide, and then I'll go back into the questions. Ultimately, this is where we ended up. We started with some sort of idea and ended up with an actual product and all the steps in between. So with that, I am going to turn it over into questions. I see Irene. Where does the ISO 9001 certification enter into this process, and how are design changes affected? I'll start with that. Boy, it enters in everywhere we go. We have an ISO process for every one of our core functions. New product development is one of those. So we have a process map that we need to go through. We have check boxes we need to check before we can move from that ideation to concept to development to launch. We have to say, hey, we've done all of these things. And then on our engineering side, we have to do all of our documentation. So that says exactly what all needs to be documented in order to show what the product is, how it's built, what the tolerances are, how it goes together, what the inspections need to be, what the inspection paperwork is, inspection checklists as it goes out the door. So yeah, ISO 9001 ends up driving not just our new product development, but our entire business based on how we have it set up within our organization. Dale, anything you want to throw in there?
Yeah, frankly, the process sometimes drives engineers a little bit crazy because you have a good idea and it really should get out there, and it must go through that quality management process in order to get to the finish line. So it's a very slow, documented, regimented process of getting things from point A to point B.
Miguel has a question about tolerance in the extrusion and how that works as the die wears down. Is there clearance for having a new die made? So yes, but so dies do, as you note, wear out. They lose material on the die itself. They start to give less clean finishes. They start to grow in diameter a tiny bit, or in shape. But our volumes are so low. These are a foot each. And how many theaters do you think we renovate in a year? It's it's in the hundreds, not in the tens of thousands. So we largely, on most of our products, we don't get to the volumes that see the extrusion wear out. We end up having our product need to change for other reasons far before the extrusion wears out. So
I think we just did one run of extrusion. It was about 1,300 feet.
Yeah, exactly. So these are a foot long. That's 1,300. So we have several years worth of stock sitting there.
Be a while.
For the extruder, that 1,300 feet was almost the initial run for proof of concept. So another industry.
Inspiration for the name. That's an interesting one too. We have naming issues. So we'll get together as the committee that works on these projects, and we'll try to come up with names for things. And everybody pitches in what they think the name should be, and then we all vote. And in this particular case, Vantis won. It was, what was it? It was a combination of a couple of words. It's a non-word word.
Yeah, so the historical J.R. Clancy naming convention was to select either a noun or a verb and place the word power or shore in front of it.
Yep.
We have the power assist, the shore lock, the shore grip, the power lift. We launched our Titan hoist a few years ago. We have our Helios hoist. So we've gotten a slightly different approach there, slightly Greek mythological name sounding. We looked at the word vantage because one of the things about this is you're able to move around the stage, get the correct vantage point to see what you might want. But we did a patent trademark search for vantage, and there's actually a home automation company that does like Crestron style automation with that trademark. So we would have had a conflict there that we weren't able to do. So we tried to merge that with the Greek mythological sound. Really theater, we get our roots from the Greek anyways, right? So vantage and mythology mixed into one.
Wow, Dale and Patrick, so much information that you just shared with all of us and managed to pack it into an hour. It sounds like there's stuff you didn't even get a chance to talk about. So thank you for that. Normally we'd say, let's have some more questions, but we are at just about 1 o'clock. So I guess what I'd love to ask is, can folks reach out to us and can we put them in touch with you if they have more questions in the future?
Absolutely.
About this process? Fantastic.
Absolutely. You have our email addresses. I'll put my email address right here into the notes for anybody who wants it. And feel free to contact me about anything. If you have questions about what we did, what we do as a company, what my favorite show is, any of those, we're happy to chat.
Same here. I'll put my email address out there for everybody as well.
Fantastic. Thank you both. Thank you everybody for joining us. I want to be, respectful of everybody's time. We're at just about 1 o'clock. So if you have to leave, you can be about your way. If you have some more questions, go ahead and throw them in the chat and we'll see if we can squeeze 1 or 2 more in. But thank you all very much. And keep your eyes open for announcements about our future First Fridays. We're looking to do one on January 8th. We'll announce more about that soon. Thanks, everybody.